The next two examples that I'm going to do both involve motion. They have to do with speeds and times and distances. And in these problems, there's a relationship I'm going to use to help me set these problems up. And that is the distance you travel is always your rate or your speed times your time. So if you multiply a speed times a time, it gives you a distance. So number 5 says Kelly and Joe are in a marathon. If Kelly can run 7 miles per hour and Joe can run 6.5 miles per hour, how long before they are 1 mile apart? So what's happening in this problem is you could assume that these two people start at the same time in the same place, but Kelly is running faster than Joe, and so she's moving ahead of him. And we want to know at what point in time is she 1 mile in front of him? When is that distance between them 1 mile apart? So first of all, what are we even solving for in this problem? How long before they're 1 mile apart means I'm solving for time. So my unknown is the time. I might call that x. Feel free to use t if that makes more sense to you. Now I think I'm going to organize the information in this problem in a table. So my unknown here is time. That's going to be x for both of these. I don't know how long they're running for. I do know the rates. I know that Kelly runs 7 miles per hour and Joe runs 6.5 miles per hour. And then the idea is to get the distance that each of them run, I can use this formula. Distance is always rate times time. So Kelly must run 7x miles and Joe runs 6.5x miles. So now that I have expressions for the distance that each of them travels, I can write my equation. If I take a look at this picture, the equation that I'm going to set up has to describe the fact that the distance between them is 1 mile. So if I take the distance that Kelly travels and I subtract the distance that Joe travels, the difference between those distances has to equal 1. And this is my equation. Or if it makes more sense to you when you look at this picture, you could take Joe's distance, which is 6.5x, and add the mile, and that has to equal Kelly's distance. Now to solve this equation, I'm going to combine like terms. I get 0.5x equals 1. And then I think I'm going to clear the decimals. I can do that by multiplying by 10, which is the same thing as moving the decimal one place to the right. That gives me 5x equals 10, or if I divide both sides by 5, x equals 2. And that's my answer. I'm just looking for that time. So it sounds like in 2 hours, they will be 1 mile apart. Let's do one more example of a motion problem. This problem says Nancy drove 2.5 hours in rush hour traffic. When traffic eased up, she was able to increase her speed by 40 miles per hour and drove another 4.5 hours. If the entire trip was 362 miles, how fast did Nancy drive? So this time I'm actually solving for a speed. Oh, and I didn't finish reading that. How fast did she drive in rush hour traffic? So my unknown is actually her speed. That's what I'm going to call my x. Once again, I'm going to make a table to organize the information. And there's two different situations again. We have information about her driving in rush hour and then after the rush hour is over. So I'm trying to find her rate during rush hour. So that's my x. I do know the time. I know that she drove for 2.5 hours. I think I'm going to write that as 2.5 in this problem. And then after rush hour, she drove for 4.5 hours. So I'll write that as 4.5. And let's see, it says, oh, she increased her speed by 40 miles per hour. So her speed after the rush hour, we can take her original speed, which was x, and add 40 to that. Now, just like in the last problem, the distance that she travels has to be her rate times her time. So in rush hour, it would be 2.5 times x. And after rush hour, it would be 4.5 times x plus 40. So distance is always rate times time. Now, to get the equation, I'm told that the entire trip, the total distance she traveled, was 362 miles. So if I take those two distances and I add them together, that has to equal 362 miles. Now I have an equation that I can solve. I can get rid of parentheses. So I distributed the 4.5, and then I'm going to combine like terms. I get 7x plus 180 is 362. I want to get the x by itself, so I'm going to subtract 180. So 7x equals 182, and then I'll divide both sides by 7. 7 goes into 18 two times, remainder of 4, and 7 goes into 42 exactly 6 times. So x equals 26, and in this problem, let's see, how fast did she travel in rush hour? Oh, that's all they're asking us for is the x, and so in rush hour, she must have been moving at a rate of 26 miles per hour. Okay, I've got two more examples, and both of these examples involve money. So let's start with example 7. A bank teller is counting $20 and $50 bills. If there are 6 times as many $20 bills as $50 bills, and the total amount of money is $3,910, find the number of each denomination. So we need to find the number of $20 bills and the number of $50 bills. Those are unknowns. Let's see, it says there are 6 times as many $20 bills as $50 bills. So if I let x equal the number of $50 bills, then the number of 20s has to be 6x. Now, to get my equation, I know the total amount of money is $39.10, and so I'm going to need to come up with an expression for the amount of money that each of these groups of bills contains. So if I have 6x 20s, and each of them is worth $20, the value of all those 20s has to be 20 times 6x, or 120x. The 50s are all worth $50. I have x of them, so the total value would be 50 times x. That means my equation would be adding these two numbers together. The sum of this money has to equal that total, $39.10. So to solve, I'm going to combine like terms. I get 170x equals 39.10. Divide both sides by 170. I think I'll reduce by a factor of 10. So now I've got 391 divided by 17. 17 goes into 39 two times. And goes into 51 exactly 3 times. So it looks like x is 23. Now we wanted the number of each denomination. So I've got 23 50s. And then if I multiply 23 times 6, I get 138. So 138 20s. All right, my last example involves interest, which we talked about a while ago when we were talking about percentages. It says a college student earned $6,200 during summer vacation working as a waiter. The student invested part of that money at 9% and the rest at 6%. If the student received a total of $441 in interest at the end of the year, how much was invested at each rate? So I think I'm going to organize my information in a table again. And in this problem, we're trying to solve for the amount invested. So that's my unknown, is how much did I invest at each rate? Some of the money was placed in at 9%, some at 6%. So I think I'm going to call the amount invested at 9% X. And the amount at 6%, I can't call that X because it may not be the same amount. All I know about the investment is that the total, if I add those numbers together, has to be $6,200. So if I put part of the money, X, at 9%, then the rest of the money, whatever's left over, has to go at 6%. And so if you have $6,200 total, whatever's left over would be $6,200 minus X. The idea is if you take away X, that's what's left over. Now I know the interest rates. I'm going to write them as decimals so I can put them into an equation. So the 9% becomes 0.09, the 6% becomes 0.06. Now to get the interest is going to be the interest rate times the amount invested. The interest is 9% of X, which we can write as 0.09 times X. Technically, the interest is the part, and we're taking the percent times the total to get that part. So then the interest earned in the second account would be 0.06 times 6,200 minus X. Now for my equation, if I add together those two interests, the things in that last column, the total amount of interest has to equal $441. So if I add those interests together, I get $441. So now I am going to get rid of parentheses. So I distribute the 0.06, and then I think I'll combine like terms, although you could clear the decimals right now if you'd prefer. But let's see, 0.09 minus 0.06 is 0.03x. To get the x by itself, I have to subtract the 372. So 0.03x equals 69. Now I think I'm going to get rid of those decimals. I want to move the decimal 2 places to the right. The 3 is in the hundredths place. So I'm going to multiply both sides by 100. That gives me 3x equals 6,900. So to finish, I divide both sides by 3. And x equals 2,300. Now I want the amount invested at each rate. The $2,300, the x, I said was put into the 9% account. And then to get the amount in the 6% account, I have to take 6,200 minus x. So 6,200 minus 2,300. And that is $3,900. So $3,900 was invested at 6%. All right, that's it for this lesson. I know this was a long lesson. Please don't give up on these problems. They really do take practice. And what I really want to stress is when you're working on word problems, I never expect to get the equation right away the first time I read the problem. I really have to break the problem into smaller pieces. And so focus on that first time you read the problem. Don't get overwhelmed by all the words. Just focus on that last sentence. That's how you're going to define your x. And then you read the problem a second time to pull that information out. As always, if you are struggling with this section, please feel free to send me an email. I'm happy to meet with you, or perhaps I can help you over email.